All right, so let's continue talking about simplifying these, but now we're going to be multiplying and dividing. All right, so if you notice in these steps, it walks you through how you're going to do this, and you're going to find that it's actually no different from what we just did. All right, you just have, instead of one ratio, you have another ratio. You have two. All right, and when you divide, think back to when you learned how to multiply and divide fractions in middle school. How did you divide fractions? What did you do to the second fraction? You did the reciprocal of it, and then you changed division to be multiplication. So that's what we'll be doing today when we do division. All right, so let's do this example of multiplication. All right, so what should we try to do to all of these expressions? Simplify, and the way we've been doing that, as Miguel said, is to factor it. Okay, so what about this x minus 3? Can I factor that? No, so I'm just going to bring down x minus 3. Over, what about 4x plus 20? Yeah. What do they have in common? 4. So I factor out 4, and what is left? X plus 5. All right, again, mentally distribute that to make sure that it checks out. 4 times x is 4x. 4 times 5 is 20. So times, can't do anything with x plus 5. Over, what about x squared minus 9? What is that? That's it, and what did we call this last semester? What is that an example of? Somebody said it. Dots. What does dots stand for? The difference of two squares. Very good. For the record, that was not Guillermo getting it correctly. Noted. All right. So we should make sure at this point that everything is factored. Looks like everything is. So we can start to cross out things that divide to make 1. So even though x plus 5 over here and x plus 5 over here are not in the same expression, I can still do what? I can still make them become 1. So just make sure that you're aware of that. I never really explained that a couple years back, but I noticed last year that some students were not crossing out things because they weren't in the same expression. All right, but that's the same idea as doing like 1/2 times 2/3. I can still cross out these 2's and make it 1/3. Okay, so just keep that in mind. Yeah, clear. Okay, what else can I cross out?
X minus 3.
X minus 3. All right, so that's going to leave me with
4x plus 3.
Great, but where is that? And I heard somebody say, since everything got crossed out in the numerator, we need a 1 in the numerator. No. All right, so that would be our simplified expression here. Did we do any multiplying?
No.
No, so that's what I'm saying. Multiplying and dividing really is not multiplying and dividing. It's just more factoring, which had to factor more stuff. All right, now, notice what does it say for the second part of this? So does that mean that I need to continue and do the values that x cannot be equal to? No, it says assume they're all defined, so I actually can be done now. But let's imagine it didn't say that. Let's imagine it didn't say that. What values can x not be? -5, 3, and -3. All right. I had a few conversations walking around with students with the last at your boards about the fact that some of you were putting values that made the numerator become 0, right? Or putting, so in this case, they both cross out. But on the examples from the last at your board, make sure you only do the ones that are in the denominator and before you cross stuff out. Okay, so don't forget that. Any questions?